not good.
Are you saying also today?
No.
No, I thought we were going like 3.6.
No, this is still 3.5. There's one more type of function they have in here, which is the cost function C of x. C of x is the cost for producing, I'm so ashamed of myself. The cost for producing x items. So the thing you want to keep straight is it is the cost for producing all x of them. We're going to change this in just a second. Okay, we're going to have something called a marginal cost. So right now, C is saying how much it costs to produce all x of the items. Okay, all x of them. Then there's average cost. Has nothing to do with the derivative at the moment. Average cost function. So what you do is you take the cost for all of the things. Right? We're going to call this C bar. Right? Bar is used for average quite often in statistics. So C bar is the average cost function. And all we're going to do is take the cost for producing all of those things and divide by the number of things. So it's the cost function divided by x, by the variable x. Okay? That makes good sense for being an average, right? If you produce 1,000 things and it costs you $5,000, then on average, each one costs $5 to make, right? 5,000 divided by 1,000.
What's that line stand for?
Average.
Average.
Yep. No questions about average cost function. All right. Now we're going to talk about marginal cost. That's really what we're trying to get to, but they do have some questions about the average. Marginal cost function. Sorry, just marginal cost, not function. Marginal cost. The marginal cost is cost of producing one more item. If you increase your assembly line, so it would make one more thing per day or something, right? How much would producing that extra thing cost you? That's what marginal cost is. Okay?
Don't marginal costs get lower and lower as you produce more and more?
You hope. That's how you want your curve to be. Yeah. If not, you need to re-examine your factory or something. Yeah. Or your workers. Yeah, that too. Yep. So the cost of producing one more item, whatever you're starting at. So what would be the cost of producing one more item in terms of our notation here? Well, it would be the cost of producing x plus 1 things minus the cost of producing x of them. Agreed? Whatever x you pick. So if I want to know the cost of producing the 1,000th item, I'm going to take the cost of producing 1,001 things and subtract out the cost of producing 1,000 of them. It will leave me with how much it costs to produce that one extra one that I wanted to make. Yeah?
This is based off a limit, because the further you go down, the cheaper it gets to make, but it'll never reach zero. You see what I mean? You'll never produce it for free. You'll produce it at such a cheap rate that it's eventually going to get there. Do you know what I mean?
Yeah, but in most cases, it will never even come close to zero. It will probably come close to some other constant. Right? Yeah. There's other things involved in these cost functions that are going to prevent you from even getting close to that zero ideal for your marginal cost. All right. So that is exactly the marginal cost. That is the exact cost of producing the next item in the chain. Okay? What we're going to do is we're going to approximate this thing. We're going to approximate it with the derivative. So the derivative will not be exact this time, because it's not telling us what a derivative tells us. We're going to use it to tell us about the marginal cost. And the derivative is not directly the marginal cost. It's going to tell us about the marginal cost. So we're using the derivative to approximate the marginal cost. And it's done like this. Since cx plus 1 minus cx takes the form of the numerator in the definition of a limit, I can play a little game. If we took cx plus 1 minus cx, we divide it by 1. Okay? So that's exactly the marginal cost right now. Divided by 1 does nothing to an expression, right? But all this is is the change in cost. This is the change in production. You're producing one more item, right? That's the change down there. And up here, this is the change in the cost due to that extra item produced, okay? So you have a rate of change here. If you were to take the limit of this expression, I'm going to say as delta x goes to 0. Okay? Right now, the 1 is the delta x. That's the change in production. So this would be written more concisely as delta c over delta x, change in cost over change in production. As delta x goes to 0, this is a derivative. Okay? It's a more concise notation. The delta notation is more concise we had before. It's the exact same thing. So this is c prime at x. Okay?
And so wait, what are we trying to do right now?
I'm trying to show why you're allowed to use the derivative to approximate this exact thing over here.
Okay.
It's because this takes the form, this exact equation here, takes the form of a difference quotient. And a derivative is a limit of a difference quotient. So if I take the limit of this expression here, as the bottom goes to 0, right? If I replaced 1 with a delta x in a sense, and I made it incredibly small, make this a delta x here, and this is going to head towards the derivative itself at x. So now we can say that this expression here, the original cx plus 1 minus cx, is approximated by the derivative at the previous production amount, not the new production amount. All right? Okay, that's the big finish there. You can approximate how much it's going to cost you to produce the next item by taking the derivative and plugging in the amount of items you're creating right now. That will tell you about how much the next one's going to cost.
Example.
Is that?
An example.
Yeah. You gonna try a picture? All right. Very straightforward problem. 23. Consider the following cost function. C of x is negative 0.001, sorry, too many O's, negative 0.01 x squared plus 40x plus 100. The interval we have to worry about is 0 until 1500. So they're only going to let us produce 1500 things at most. Find the average cost and marginal cost functions. Okay? Average cost and marginal cost. Okay, average cost is right there. Let's complete that first. C prime. I say prime. C bar. C bar x. We need to compute average cost. Okay, so that is this function itself, just divide by x. In the textbook, they do tend to cancel x's wherever possible. So the way they like this to look, at least in the textbook, is